Hey everybody, welcome to the channel. This video is about building this, the Stretch, a 3D printed 1.6 meter V-tailed glider using the lightweight power pod and the foaming lightweight PLA to make this 63-inch lightweight motor glider. I will discuss the power system, setup, and show you a little of what the Stretch can do. Nice! Available now on the SoarKraft website. We're going to print, build, and fly the Stretch. Thanks for watching. Please like and subscribe, and check out my other videos about printing, different materials and testing, and flying these SoarKraft designs to the limits of what's possible. This channel is funded by viewers like you purchasing my files on my website for printing planes just like this, and helps me to continue to refine, develop, and share new ways of making them better, faster, and cheaper to hopefully benefit everyone. Or at least to have a good time. Nice. The plan of this build was to make a Stretch with the power pod as light as possible, but without using expensive parts. Using foaming lightweight PLA, a two-piece wing, a single servo tail, removable tail fins, and an inexpensive but light power system. And no added balance weight. Would it have enough power? Would it be fun and easy to fly? Well, I was pleasantly surprised. To do this build, I used the Stretch airframe and the power pod option. The Stretch has the wing and the fuselage files. The wing builds just as the included instructions, but the fuselage will be built with the power pod parts, specifically the power pod wing saddle and the shorter power pod nose and door found in the lightweight supplement, which also has instructions. This may sound confusing, but I'm just using this instead of this, so I can mount the elevator servo under the wing. And instead of using these, I'm going to use this, which is the shorter version of the power pod nose. And with everything in the fuselage, it balances perfectly without any added balance weight. You can build yours however you want, but pre-check the balance with all the parts before you glue the fuselage together. It helps eliminate surprises when you get it all put together. My current printer of choice is the Bamboo Lab X1C, but just about any printer can print the foaming lightweight PLA. The print settings are key to get any printer to print these parts with this material, and best results are one part at a time. Check out my video guide on setting up PrusaSlicer with any printer for printing this lightweight foaming PLA. Start with the SoarKraft test part and try out these settings. Once you're happy, you're ready to print the rest of the plane. For the Stretch, there are detailed instructions for the fuselage and separate instructions for the wing, detailing the parts to print, additional parts needed, and how to put them all together. I used PrusaSlicer for this project. Orca and Bamboo Studio allow you to load all of the parts at once into one project and still print them individually. It's a nice way to stay organized. And you can check your slicer settings before printing by taking the approximate weight from the instructions based on regular PLA density and 100% flow, and factoring in the density and flow ratio of the lightweight material to come up with an estimate to check your slicer value. The values don't need to be exact, but close, and the actual parts will come close to this value too. Use this to print all the lightweight parts. Load all of the stretch fuselage parts and turn off the ones you don't need. And I loaded the power pod parts onto a separate plate. And then on a fourth plate, I put all the little bits that I will print with PLA+. I do suggest supports for the servo covers for best results. While everything's printing, we'll talk about the other bits. This lightweight power pod airframe uses the same pultruded carbon as the slope version. I will be using the 8mm carbon tube for this lightweight build. I do suggest getting an extra 1x4 strip and a 2mm rod when ordering carbon. They're inexpensive to add and useful in other areas. Like this extra reinforcement for the tail I will get to in the build. See my Pultruded Carbon video for sources. This will use 5 of these ultra cheap servos, 4 in the wing and 1 for the tail. Easy connectors and Z-bins for the wing push rods. And an 032 wire with this Dubro clevis for the tail. And a FR Sky 6-channel receiver. I know, I said I was going to stop using them, but I haven't found any better alternatives. This is the Surpass 2204 1400 kV motor, used in my original lightweight power pod build. If you want to see details, go here. An inexpensive system with 120 gram total weight. I'm using the ZTW 15 amp ESC. It can do braking for a folding prop and only weighs 12 grams. I did have to change the motor and battery connectors to match the other components. And this is the 3S LiPo battery I'm using with the XT30 connector, using a strip of Velcro to hold it in place during flight. I also paired it with the 3D printed folding prop. In this lightweight power pod stretch build, 120 watts is more than enough. And links to the free files are on my website. This is the super thin CA we're going to use to glue everything together. A paper towel on the work surface to catch drips, and fold it in half, it's less likely to glue itself to the work surface. The wing builds exactly the same as the slope version and the instructions. My other video is very long but very detailed about how to do this. Silicone hinges are highly recommended, and servo mounting is exactly the same too. Hot glue is still my preferred method of mounting. It's easy, secure, and very versatile. The heat also helps form the cover to fit flush. If you make a mistake or need to change a servo, a little isopropyl alcohol will make the hot melt peel right off. The stretch servo covers have a relief to fit the wider 9-gram servos. Square tube spar, 1x6 adder, 2-piece wing ready for fuselage. Alright, fuselage parts and carbon pieces. The tail fin carbon is made from leftover wing strip pieces. The longerons are cut from 2mm rod. But because of the weird lightweight power pod, the cut length is different than the instructions. The full length longeron is approximately 690 millimeters, leaving the perfect 310 millimeters for the upper carbon support. There is one more 2mm carbon rod opportunity in the stretch, specifically the fuse tail piece. This is not required, but reinforces this section, which holds the larger stretch tail fins. This was only ever a problem in a really hard landing, but only 60 millimeters in length if you got it. With all the carbon cut, it is time to test fit everything. File, sand, and adjust. So the fuse in order goes: power pod nose lightweight, fuse front for stretch, fuse wing saddle power pod, fuse mid 1, fuse mid 2, and fuse V-tail. Next, tighten up all the joints and check to make sure the longerons are all the way in the tail. The longeron goes all the way back to the first fin carbon strip channel on both sides. A backlight can help see the carbon's position. Up front, it should stick out from the motor mount surface just a little. Adjust if needed and mark the exact position for gluing. The upper support should go from the back side of the wing saddle to the front opening. I'm going to use the plastic T-nuts. Don't forget to thread them before you install them. Dry fit everything in the fuselage. The tail, servo, motor, prop, battery, ESC. And check the balance. The perfect position worked out to be only 10 millimeters back from the front wing bolt, instead of 15 millimeters from the heavier PLA build. I think this is because the 4 servos in the lightweight wing change the balance with it and the fuse. So the 10 millimeter is a better reference point for the lightweight PLA stretch wing. If you're happy with the fit and the balance, you can take everything apart and get it ready for glue. Again, this is the super thin CA we're going to use to glue everything together. A paper towel on the work surface to catch drips. The carbon needs to be anchored well on each end to hold the layers together. The thin CA works best for this and can wick the whole length. You can glue back to front or front to back, but make sure all 4 carbon rods are anchored on both ends. For the back to front method, make sure the rods are all the way seated in the tail. Drip glue down the rods. Glue the joint. Wipe off excess glue. Repeat this drip on carbon and glue the joint method on every joint forward. At the back of the wing saddle, lay the assembly sideways. Add glue to the back of the upper carbon before gluing the lap joint. Once the upper carbon is tacked in place, continue moving forward. For the alternate front to back method, align the carbon rods in the nose with the edge for the top and the marks for the bottom, and a nice gap to the next part. Drip glue onto all 4 rods. Let it dry long enough that the carbon does not spin or move in the nose. Wipe as necessary. When the rods are well anchored, you can move on to glue the joint of the next part. And repeat for each piece, dripping glue down the rods and then gluing the joint all the way back to the tail. Before gluing the tail on, make sure it can fully seat on the lap joint. If it doesn't, you can cut the carbon rods a little if something moved. If it fits, glue on the tail. Add glue to the little opening for the back of the carbon rod, both sides. Then finally, for either of these methods, stand the fuselage on its tail and add a couple of drops of thin CA to the front of the 4 carbon rods on the power pod nose. This will ensure that the motor mount area is well secured to the rest of the plane. Wipe off any excess glue. Add the 4 threaded T-nuts. A wing bolt can help get them in place. And add glue. Set the whole assembly aside and let it dry. Tail fins built just like the slope version. Carbon strips stick out 16 millimeters and 5 millimeters for the control surfaces. Silicone hinges. My V-tail video fully details how to build these and set up the single servo tail push rod. Please watch my video for full details on how to do all of this. And we can move on to finishing this up. So with everything put together, we can check the balance. This one is balancing right on the features, but there's lots of room to move the battery back and forth. A little bit nose heavy is way better than tail heavy. And I add a mark so the battery is always in the same location. So ready to fly weight is 565 grams with 220 grams of thrust. Not a rocket, but should be a good glider. For this video, I'm using this FrSky X14 radio with a modified Mike Shellum's eSoar Plus programming. Available from rcsoar.com and is in the Ethos hanger. Originally designed to work with the X20 radio, and I'm not quite sure why it would not identify the SH button on the back of the X14, but I couldn't get it to work. I eventually figured out how to change the cal and motor arming switch to use the SE momentary switch, and the rest of the program worked fine. This is my first Ethos operating system radio and a bit of a challenge to jump into, but I got it to work. Mike Shellum's setup guide is very detailed and can do some really cool mixing. This is full crow, but I could probably get more flaps if I wanted to, but a good place to start. And elevator throws do not need to be much. I have dual rates set to 100% and 60%. So there's a hair of up elevator. This is maximum throw. And this is low rates right here. So this is throttle elevator compensation. A little bit more down than I thought there was going to be. But I usually have to add a little, so not sure what might be different with this build. It's nice to have. All right, it's time to charge the batteries and go fly it. So the programming I showed in the last section was a result of this flying session at my local park on a surprisingly noisy morning. I've flown this plane before, but this is the first time with this radio, so it's kind of like a maiden.
All right, let's do this.
Well, that was pretty ugly. It had just enough thrust to pull out and not stall. I eventually found the trim button and got it to behave. Once it gets moving, it climbs pretty good. Not super powerful, but gets around just fine. "10 minutes flying around, it was time to start thinking about landing. And here was a practice approach.
Ow.
I can do better than that. New battery and ready to go again. Yeah, it was a little bit better. I need practice. This lightweight stretch with a power pod, it's pretty fun to fly. Easy to see, gets around well. Can climb, float, and thermal. It slows down real nice for landing.
Pretty good.
And I finally figured out the launch.
Nice.
So the stretch in lightweight PLA with the low budget lightweight power system is good fun. Easy flying, decent performance. And I'll have to try some different props and some other motors and some bigger and higher voltage batteries before I print another one in one of these materials. Stretch and power pod files on my website. Thanks for watching, hope you enjoyed the video, and see you next time.
Nice.